We are in our books on page 182. We're going to start here where it says learn, compare proportional relationships. On page 182. Everybody is getting into Clever now, okay? And things are well, right? All right. You can use tables, graphs, words, or equations to represent and compare proportional relationships. In the equation of a proportional linear relationship, y equals mx. M represents the slope or unit rate. Remember, we call that m the coefficient of x because it is a constant, meaning just a number in front of x. What if we just had x? What would be the coefficient? 1, remember? Or negative x would be -1. So, in the table, the slope is the constant rate of change, or unit rate. In the graph, the unit rate or slope is the constant rate of change, or the constant ratio y over x. Sorry, I don't know why that's wonky. You can also find the unit rate from the point 1r, where r is the unit rate. That sounds like a lot of verbiage to tell you that. But we're going to look at some examples about what they're talking about. The cost y is directly proportional. This is page 183. I didn't turn the page or anything. Just moved over. The cost is directly proportional to the number of breakfasts x. So y is equal to 2x. So the cost is 2 times however many breakfasts there are. So the number of breakfasts for 0 breakfasts, we're on page 183. For 0 breakfasts, it costs $0. So they put a point there. For 1 breakfast, when they put a 1 in, 2 times 1 is 2. It costs $2. So they put the point 1, 2. So every time the number of breakfasts goes up 1, the y or the cost goes up 2. So they took the change in y over the change in x. See, the constant ratio is y over x. So 2 over 1 or 2 would be our slope here. So this is kind of just another way of showing us what we are looking at on Tuesday with those notes, and hopefully you practiced that some yesterday. The distance y in miles that can be covered by a rabbit in x hours can be represented by the equation y equals 35x. So the distance that can be covered by a grizzly bear is shown on the graph. So we're taught, first they gave us an equation for rabbits. This is rabbits. And then they gave us a graph for grizzly bears. So first we would find the speed of the rabbit. The speed is the unit rate. So in the equation y equals 35x, the slope or unit rate is the coefficient of x. Bless you. Remember, we know that y equals mx. When it's in that form, this is not only the coefficient, but our slope. So the unit rate, what is m here, is what? 35. 35 miles per hour. So we can get that from an equation. You have to know how to get that from the equation. And then you have to know how to get it from the graph. So find the speed of the grizzly bear. And the graph slope or unit rate is the constant rate of change. So the slope is also equal to the point when x equals 1, because 30 divided by 1 gives us a unit rate, right? This is saying 30 miles per 1 hour. So the grizzly bear goes 30 miles per hour. Do you see how we can find the slope with the 0.1r? That is, of course, when we start at this 0, 0. So, which animal is faster? The rabbit, right? So the rabbit, because 35 is obviously greater than 30. So we should be able to understand how to get the slope from the equation and the slope from the graph. That's all example 4 adds for us, okay? So then they're giving you multiple methods. We have to know how to use it choosing 2 points. So they are using the point 130 and 260. So they're taking 60 minus 30 to find the change in miles, which is 30. And 2 minus 1 to find the change in X, or the change in hours, which is 1. That way we know it is 30 miles per hour. Another way, use the rate distance over time. We can just simplify y over x, right? We could divide them both by 2, giving us 30 over 1. Or using the point 1r, in this case, what we are talking about on the graph, the y coordinate is 30 when x is 1. So the point 130 represents the unit rate, which is 30 miles per hour. So using any of these methods, the grizzly bear travels 30 miles per hour. Oh, and here we go. We've already answered this, but it's just telling you the rate for the rabbit is greater than the rate for the grizzly bear. Since 35 is greater than 30, the rabbit is the faster animal. All right, so you have a quick check here. They're giving you an equation for a dog to represent their heartbeat, and they're giving you a graph for the cat. So which animal has a faster heartbeat? So look at the equation, figure out what the dog's heart rate is. What's the slope of that line? The slope from the equation. And then from the graph, we have to figure out the slope of the line to figure out our unit right there. All right, so just take one quick minute to be sure you got that. Try and figure those out like we just did before. All right, so what is the rate of heartbeats for the dog? Make sure your phone's off. So here is our slope. This is our rate. So this is the dog's equation. So what is the rate?
3.
It's not 3. What is this number right here? 1.5. That's our rate. 1.5. This was beats per second, right? I'll just say BPS. How's that? Now we have to figure out what the cat's was. So either we look at the point 12 tells us this is 2 beats per 1 second. So we could just say 2 beats per second. Or you could use 2 points, right? 4 minus 2 is 2, divided by 2 minus 1, which is 1. 2 over 1 is still 2. So either way, we need to know how to find the rate or the slope in an equation and on a graph. So which animal has a faster heartbeat? The cat. Because of course 2 is greater than 1.5 or 1 5/10. Okay? So example 5 has us comparing proportional relationships. We're now on page 185. The cost Y for computer repairs at Computer Access for X hours is shown in the table. Macro Repair charges $23.50 per hour for computer repairs. Assume that the cost is proportional to the number of hours. Which company has the lower repair? So here we have Computer Access, and this is Macro Repair. So we're trying to figure out what each change in cost, each unit rate is. So here they're telling us our rate, $23.50 per hour. Here they're showing it to us. 50 divided by 2 gives us 25 over 1, right? So it's $25 per hour. So as the cost increases by $25, the number of hours increases by 1. So the unit cost is $25 per hour. So they're finding this rate. They've already been given this rate, and now we should be able to compare them. So from the problem, we know that Macro Repair charges $23.50 per hour. So the rate for repairs at Macro Repair is less than the rate for repairs at Computer Access. Since $23.50 is less than 25, we know Macro Repair has the lower repair costs. So you see right away, Jay, that this is going to help us in everyday life because obviously we want to save money, right? Okay. So that is 185. Check is on 186. So try that really quick. Again, they're giving you one rate and you have to find the other rate from the table. I always think it's just easiest, especially if you have a calculator, to take your amount divided by your unit to get your unit rate. Because we want one of those units would cost. In this case, our unit is in hours. So we want to know how much is earned for every 1 hour. So that we can see which job we're going to take this time. Which job would pay us more? So the only thing we have to find out here is how much is earned currently. Because we know how much the new job pays here. So we're comparing it to that. So $14.50. If we divide that in two, what do you have? $7. So every time it goes up an hour, it's going up $7.25. And notice this is going up 1. Or you can think of it like we were just thinking of it, $14.50 divided by 2. If we divide them both by 2, we end up with $7.25 per 1 hour, which is what we want, right? So currently, they're making $7.25 per hour. The new job pays $7.95 per hour. So which pays more, the current or the new? The new job. Because of course, $7.95 is greater than $7.25. And I know it doesn't seem like a ton, but when you multiply that by 40 each week, it makes a difference, right? $28.
It said 26.
Gotcha, nice. Good estimation there. Okay. So if we are applying things, I feel like everything we've been doing is applying them. So I think we are okay here as far as comparing prices. This is the same thing. All of these have been applied problems in real life problems. So for company A, the cost Y for X cubic feet of natural gas is shown in the table. For company B, the cost Y can be represented by this. So remember, M is this coefficient here. So for B, we have 53 cents per what? Cubic feet. So I would abbreviate this as feet cubed. Because it's not per feet, it's per cubic feet, which does kind of make a difference. So we just need to compare what it would be. Oh, and we have to figure out how much 125 cubic feet would be. So if we multiply this by 125 cubic feet, so I like to set them up. I love using unit rates. You'll use them a lot in conversions in science. So it's really important that you understand that whatever answer you want. So in this case, we want to know how much company B charges for 125 cubic feet. How much tells us we want to know the price. So whatever I want to know, I'm going to keep on top. And I notice whatever is on bottom here, I need to get rid of it. So I need to cancel it out. And I know I am purchasing 125 cubic feet. Notice when I write anything, any whole number, I can put it over 1. So I can now cancel out my cubic feet. And I'm left with just how much money it is, right? So if we throw that into a calculator, did you try it? Calculator may have gotten put back in the stash. So it'd be, it's gonna be more than $60. 62.50 times whatever plus whatever 3 cents is times that. So like 65, 66 and a quarter. Excellent. $66.25. And remember, this was for part B. So here, in order to find a unit rate, we have to take Y and divide it by X because we want per 1 cubic feet. So keep your calculators handy because we want to do 3750 divided by 75.
Yep.
So it's exactly 50 cents per cubic feet. So now that 50 cents is what we're going to want to multiply by 125 here. 125 cubic feet. So 6250. So this is 6250 for company A. So there's two questions. Which company charges less, A or B? Company A. And how much less? We have to do one more step, right? We have to say 66.25 minus 6250. $3. Oh, that would be a 5. $3.75. Nice. How much less? $3.75 less. So company A and $3.75. Do you see how it takes some reasoning, some problem solving skills to take what we know, the rate, right? And move on to more information, to gain more information from what we know. Okay? So today, I want you to do this check. So this is part of your practice on page 188. And then I'm really quickly right now going to go over 1 through 4 and leave you with that check and page 190. Okay, so let's review a little bit. On page 189, book sales over several days. Find and interpret the slope. Find and compare the unit rate to the slope. Okay, so $1,000 over how many days? 3 days. So $1,000 per 3 days. So this is how I would find the unit rate, right? What's 1,000 divided by 3? You're gonna get something not nice repeating, right? $333.33 repeating.
That's a lot of money.
So here is our rate, $3.33 repeating cents. So essentially, when things happen like that, we round to the nearest cent, which we would keep it at 33 per day. And then here, we would say, excuse me. If we're looking at these points, we have 6, 2,000, and 3, 1,000. So essentially, we're going to end up with the same thing because 2,000 minus 1,000 is 1,000, and 6 minus 3 is 3. So our slope is also 3.33 repeating, right? And what that means is for every day, sales go up $333.33. We have to know what the slope means, right? That's how we use it in real life. So the cost Y of renting a snowmobile, this is number 2 on 189, for X hours is a proportional relationship. These would not be linear if they weren't proportional relationships, right? They were just willy-nilly all over the place. This can be represented by the equation y equals this. Graph the equation, then find and interpret the slope. All right, so I like to set up a table. For 1, it would be 0. I'm sorry, for 0, it would be 0. For 1, it would be how much? 33.75. For 2, we would be adding on another 33.75, so 50, 67, 50? Is that what it is? Can you guys help me out here? No, maybe. So find a couple points. 0, 0, we've got. Yes, good. And 1 is 33, so just above the 30 here, because this is jumping 30, so it's barely above the 30. 2, 67.50. So I don't like that they don't give us like nice ones, but you kind of get the idea that this would be increasing like this. So you might snag your snag your planner or your folder or something to make it continue on. I don't really feel like this helps us with the slope, but it kind of shows us what that type of slope would look like, I guess, per se. But we can find the slope because we know that in any equation y equals mx, this is our slope. So here, our coefficient, what is our slope? 33 7/75. Do you see how we find it from our thing too? So hopefully you got that yesterday. Number 3, by the end of its 4th week, a movie had grossed 9.2 million. So we know week 4, this is the point 4, 9.2, and luckily our graph is in $1 million. Assuming that's proportional, if we graphed that, it would start at 0, right? Because you can't make any money from doing nothing. And we would be at 4 and 9.2, which is way up here. Kind of like almost a quarter of the way to the next line. So this is a pretty steep slope. Well, not the steepest, but it's fairly steep. And to figure out exactly how steep, to figure out our slope, we can find our unit rate, how much they make each week. So 9.2 million in 4 weeks, you should have gotten 2.3 million per week. This would be both your slope and your unit rate. For sure. I'll take it. All right, the amount of power Y solar panel A can produce with an area of X square meters can be represented by this equation. So here we are, just like we've been practicing. We have an equation that we're comparing to the graph. So solar panel A, here is my rate, right? The power is 1020 per square meter. So that's M for A. M for B, we have to figure out. And this is the point 1200. So couldn't we say that our rate is whatever the Y value is when X equals 1? Remember that? 1R. So we're comparing 1200 to 10,020. Which solar panel can produce more power? Solar panel B. So we explained that A is equal to 1020 per square meter. I would just say meter squared. And B is equal to 1200 per meter squared. And we know that 1200 is greater than 1020 or 1020. So it does ask you to explain, so I do expect you to have something like show what your things are. show what your slopes of the two are. Okay, so now you have not a ton of time, but at least do the check on page 188 and try and get started on 190. We're kind of gonna be moving here pretty quickly. We're gonna start 4-2 tomorrow, but if you don't get to 190, I feel like we have gone over those things, but definitely do the check on 188, okay? Make sure you're understanding because we're adding one more layer tomorrow.